The central white matter of the cerebrum is deep to the gray matter that makes up the cerebral cortex. It's made up mostly of myelinated axons that are grouped into bundles called tracts. Association tracts connect different regions of the cerebral cortex in the same hemisphere. We have little short tracts composed of arcuate fibers. They connect neighboring gyri within the same lobe. We also have longer association tracts called longitudinal fasciculi. That just means bundle. So they connect the gyri in different lobes of the same hemisphere. Commissural tracts are bundles of axons, myelinated axons that connect different regions in different hemispheres. So it connects the right hemisphere to the left hemisphere. The corpus callosum is the largest of those, and it is located there in that longitudinal fissure. And then we have projection tracts, which link the cerebral cortex to inferior brain regions and the spinal cord. So here you can see the blue, that is your corpus callosum. Remember, we talked about that on the previous slide. So it is connecting the right and left hemispheres. And here we have those projection tracts that are linking the cerebral linking the cerebral cortex to the lower parts of the brain and the brain stem. Here you can see they decussate, which simply means to cross over, or decussate, whichever you prefer, crosses over there very near the medulla oblongata in the brain stem. So this allows the right hemisphere to control the left side of the body and vice versa. Each of our two hemispheres of the brain are specialized for certain tasks, and we call that cerebral lateralization or hemispheric lateralization. The higher order centers in both hemispheres tend to have different but very complementary functions. So the left is the categorical hemisphere, and that term simply reflects this hemisphere's function in categorization and identification. So specialized for language, putting things into categories and analyzing. The right side is called the representational hemisphere because it's concerned with visual spatial relationships and analysis. So this is the seat of your imagination, your insight, musical skill, artistic skill, perception of pattern and spatial relationship, and comparison of sensory information such as sights and sounds, taste and smells. This lateralization of the hemispheres develops early in life, usually before you're 6 years old. So in a young child, if you have damage or something happens and you have to remove a hemisphere, the other side will usually take over before lateralization is complete. There are other aspects of lateralization that differ between the sexes. So women have a thicker posterior part of the corpus callosum due to additional commissural axons in that area. Adult males tend to have more lateralization than females and suffer more loss if one side is damaged. This cerebral lateralization is also correlated with handedness. So right-handed people tend to have slightly different lateralization patterns than those who are left-handed. About 95% of the population, the left hemisphere is the categorical hemisphere, and that correlates with about 90% of people being right-handed in the population. Not so with the left-handers, though. They may have either hemisphere be the categorical one. Epilepsy is a neurological disorder where the neurons are firing action potentials rapidly and too frequently. This causes seizures that can affect both motor and sensory functions. Now, a lot of times this can be controlled with medications, but if the medications don't work, then surgical intervention may be necessary to remove the part of the brain that's the source of the seizures. Sometimes that helps. Other times, in very severe cases, a more drastic form of surgical intervention is needed, and that's called a hemispherectomy, where the corpus callosum is actually cut, and that interferes with the lateralization or with the processing of stimuli from one side of the brain affecting the activity on the other. So the remaining hemisphere, sometimes if a hemisphere is removed, which is the classical definition of hemispherectomy, the other side of the brain may be able to take over some of the functions of the missing hemisphere. This usually is much more successful the younger the patient. A cerebrovascular accident is what we commonly call a stroke, and it's caused by a reduced blood supply to a part of the brain. Now, this can be due to a blocked vessel or a hemorrhage, but if the impaired blood flow lasts longer than about 10 minutes, brain tissue starts to die. So symptoms include loss or blurring of vision, weakness or slight numbness, headache, dizziness, walking difficulties. Each side of the brain controls the opposite side of the body. So remember, if you have a CVA on the left side, you should see symptoms on the right side. A TIA is a transient ischemic attack. Transient means it starts fast and goes away. So this usually is temporary and reversible. An ischemic stroke is most commonly caused by a blood clot, or atherosclerosis or cerebral edema, swelling, of course. And a hemorrhagic stroke, hemorrhage means bleeding. So if a blood vessel is ruptured, we call that an aneurysm. Of course, that is going to impair blood supply to that part of the brain.